we are ready to figure out what the product rule actually is after spending an entire video talking about what it isn't. Okay, so I've got up here on the board the correct limit that we need to evaluate. We had this last time, and we saw that this is not equivalent to just multiplying together the two limits that would correspond to the individual derivatives of f and g. So if here's my function f of x times g of x, I've got 2 points with x values of x and x plus h, and this right here is just the difference quotient, or the slope of the secant line connecting those points. Now, a little bit of preparatory work about notation about, or a little bit of a warning about what I'm about to do. Sorry, lost my train of thought there. All right, there are times when, if you're watching these videos, if you're having a good day, you're a step ahead of me. You can say, oh, we're just doing some algebra. I know how to do algebra, and you've got it written down at the same time or even before I do. I don't expect that that happens to all of you all the time, okay? There's nothing wrong with you if sometimes you're sort of a little bit behind and trying to understand things. But for those of you where that happens a lot, don't expect it to happen here, okay? Your job here is not to predict what I'm going to do next. I don't think it's obvious. Your job is to understand why it's legal for me to do what I'm doing. Why math allows me to do what I'm doing. Not what my motivation is and why I think this might be useful, but just why it's legal. Okay, so here's what I'm going to do. I'm simplifying this limit. I'm going to say it's the limit as h goes to 0. Keep the bottom the same. We've got f of x plus h times g of x plus h. And we've got minus f of x times g of x. But I'm going to insert some extra stuff in the middle. I'm going to add a minus f of x times g of x plus h plus f of x times g of x plus h. Now, why I want to do that is not at all clear. It looks like I just made this more complicated. What I want you to do is take a moment and see, can you figure out what I just did and why it's legal? Hopefully you noticed that these two terms are exact opposites of each other. So what I've done is I've just added 0. So there are lots of times this semester already where we've multiplied by 1 in the form of something useful over something useful. Because we said, hey, multiplying by 1 doesn't change the value of things, but it does change the way things look. And sometimes changing the way they look makes them easier to work with. Well, multiplying by 1 doesn't change things. Adding 0 doesn't change things either. What I'm going to do is, by each equal sign, I'm going to just provide a brief explanation of either what I did or why it's legal. Okay? So here, I'm just going to say adding 0 does not change the value. Okay, excellent. And now I've got 4 terms on top instead of just the 2 that I started with. And I can notice the terms don't all have a common factor. There's nothing in common among all 4 of them. However, the first 2 terms do have a common factor of g of x plus h. And the second 2 terms have a common factor of f of x. So what I'm going to do is I'm going to factor out that common factor from each of those pairs. So I'm going to say this is the limit as h goes to 0. The bottom is still h. From this first pair, I'm going to factor out the g of x plus h. And that's multiplied by f of x plus h minus f of x. So that takes care of my first 2 terms. Now from the last 2 terms, I'm going to factor out the f of x. So that's going to be f of x, and that's multiplied by g of x plus h minus g of x. Okay, Excellent. Again, not at all obvious why I'm wanting to do this, but certainly I'm allowed to factor. So here my reason is just I factored. I did some algebra, and algebra is always legal in a math class. Okay, so now I want to simplify this a bit further. We're going to jump to the top of the board and say this is the limit as h goes to 0. Now what I'm going to do is I'm going to distribute this division by h. So now I've got two parts on the top, okay? And so I'm going to just split this into two fractions. So I'm going to say it's g of x plus h times f of x plus h minus f of x over h plus f of x times the quantity g of x plus h minus g of x over h. So that's just distributing the division. Okay, excellent. And I'm actually going to break this quantity in the brackets up just a little bit more, because each of these fractions I'm going to split apart into a product of two things. So I'm going to say this is the limit as h goes to 0. That limit applies to this whole thing. G of x plus h. I'm going to take that first factor on top, and I'm just going to slide it off to the side and write that I'm multiplying it by this fraction, f of x plus h minus f of x, all over h. Plus, I'm going to do the same thing over here. I'm going to take that f of x, that first factor, and I'm just going to slide it off to the side, f of x, and that's multiplied by this fraction, g of x plus h minus g of x all over h. Okay. Now, all I'm doing is just rewriting the multiplication problem. Because I know if I were to multiply something by a fraction, I could write this g of x plus h as g of x plus h over 1, and that would put the g of x plus h then on the top of that fraction being multiplied by the rest of the top. Okay, so this I'm just going to say is rewriting the multiplication. Okay, now you will notice I have 1, 2, 3, 4 pieces in here that are connected with arithmetic. These two pieces are connected by multiplication. These two pieces are connected by multiplication. And the two big pieces are connected by addition. But I know that limits commute with all the arithmetic operations. So I've got these rules that say, hey, right now we're doing the arithmetic and then taking one limit. But if these limits exist as finite numbers, then I can take the limits first and then do the arithmetic. So I can say this is going to be the limit as h goes to 0 of g of x plus h times the limit as h goes to 0 of f of x plus h minus f of x over h plus the limit as h goes to 0 of f of x times the limit as h goes to 0 of g of x plus h minus g of x over h. Now what I just used there was the sum and the product rule for limits. So I used two of my arithmetic rules for limits. Fabulous. So now all I have left to do is evaluate these four limits. Okay. And as I erase the top of the board here, I need to tell you, I forgot to tell you at the beginning of this problem, f and g are meant to be differentiable functions, so that the derivatives of f and g both exist. Okay. I should have stated that before we started this problem. If I have a function that isn't differentiable, I have no reason to expect that when I multiply it by another function, suddenly it becomes differentiable. So we're starting with two differentiable functions, f and g. Okay, so in your notes, you might want to go back to the beginning of this problem and just write that in. I apologize that I forgot to state that earlier. Okay, what we're going to do is we're going to bump up to the top of the board, and we're going to evaluate each one of these four limits. And we're going to have four different reasons for what we get. Okay, so for this first one, the limit as h goes to 0 of g of x plus h. Now, h is my variable here. X was representing the point of tangency. So x is representing a fixed but unspecified number. Okay. I'd really like to be able to plug in that 0 for h and just say this is g of x plus 0, which would make it g of x. In order to be able to do that, what sorts of limits do I evaluate by plugging in? That would be if the function is continuous. Do I know that g is continuous? Yes, I do. How I know that is because I just said it was differentiable. If you remember, in the last section, we had a theorem. It was theorem 4, I think, although the number doesn't matter. It says if a function is differentiable, if the derivative exists, that function must be continuous. So I can go ahead and plug in 0 for h here. So I'm going to get g of x for that first limit. And my reason here is I know that g is continuous because it is differentiable. I also know the function x plus h is continuous because that's just a sum of continuous functions. And so that composition is also continuous. So we evaluate by plugging in 0. Okay, now for the second limit, limit as h goes to 0 of f of x plus h minus f of x over h. That formula should look very familiar. This is the difference quotient for f. That represents the slope of a secant line on the graph of f. And when I take the limit of the slope of a secant line, I get the slope of the tangent line, which is the derivative of f. Now my reason for that one, okay, my reason for that one is just the definition of the derivative. Cool. Plus, limit as h goes to 0 of f of x. I don't see any h's in this expression. If there aren't any h's, this is constant. It doesn't look constant because it has that x in there, but it's constant with respect to h. Remember, x was the x value of our point of tangency. As we take this limit, that point doesn't move. The other point moves closer to it. So I can say this is just plus f of x, and my reason there is that f of x is constant with respect to h. And then my last limit here, that looks awfully familiar. G of x plus h minus g of x over h. That's the difference quotient for g. That's the slope of a secant line connecting 2 points on g. So there, I'm going to get the derivative of g, g prime of x. And my reason is exactly the same as it was here. That's the definition of the derivative. So, it's kind of cool. What we get, let me just write out the final result here. What we get is that the derivative of f of x times g of x is g of x times f prime of x plus f of x times g prime of x. Now, because we're just multiplying and adding, the order in which you write these things doesn't matter. What's important is that it's a sum of two products. Each product consists of one of the original functions, either g or f, and one of the derivatives, either f prime or g prime. And you're mixing them. When you have the original g, you multiply that by the derivative of f. When you have the original function f, you multiply that by the derivative of g. Okay. So basically, we can build our formula for the product, for the derivative of a product of two functions. We build it out of four functions. The two original functions, f and g, and their two derivatives, f prime and g prime. All right, we've been going for a while here, so I'm going to end this video. In the next video, I will address to what extent you're responsible for this derivation.